This video still belongs to the remainder and the factor theorems. In the previous video, we've learned how to perform long division. In this video, we will learn how to perform synthetic division and how to apply the remainder and the factor theorems. So what is synthetic division and when can we use it? Well, first of all, we can consider this as a shortcut for the long division. So we will get a way shorter procedure than it was with the long division. We can use this method for synthetic substitution, which I will explain later in this video. The only disadvantage that we can use this only when the divisor is in x minus c form. We will do our first example for the long division with synthetic division too, so we will see the results are exactly the same. Also, I will show you what can we do if we have a little bit different divisor or if we have missing terms from the polynomial. So let's use the same example as we used for long division and let's see how synthetic division works on it. In synthetic division, we only use the coefficients from both the dividend and the divisor. I'm going to copy all the coefficients from the dividend first. Then I will copy the coefficient from the divisor, which is only the constant term here. I will separate it in a box. And also make sure that you change the sign, so if you saw a negative number here, we will use a positive one here. Draw a line, but make sure that you have enough space for one row of numbers here. And we can start the procedure. So we will copy our 6 first, same way, same number as it is. Then the next step is to multiply them, this 6 with my divisor, and write them below the next coefficient. In the next step, I will add these two numbers. Be careful, in the long division, we were subtracting. Now this time we will add. Why do you think is that? Well, here we already took care of subtracting by changing the sign of the divisor. If I add negative 25 plus 18, I will get negative 7. Now the next step is again to multiply these two numbers and write the result below the next coefficient. Negative 7 times plus 3 is negative 21. 18 plus negative 21 equals negative 3. Again, multiplication comes. Negative 3 times positive 3 is negative 9. And negative 9 added to positive 9 gives me 0. Now the big question is, how can we decode all these numbers? Well, first of all, we need to separate the last number from the previous ones, as this number will be my remainder. And all the other numbers will be coefficients in my quotient. The last number will be the constant term. The second last number will be the coefficient of the linear term. And the last one here will be the coefficient of the quadratic term. So if I want to write up my coefficient, it will be 6x squared minus 7x minus 3. And the remainder is the last number I've got, which is 0. If I compare this with the long division, I realize that I got the same numbers, same quotient, and same remainder. I hope you like the idea of synthetic division, and in this example I will show you what can we do if the divisor is not exactly in x minus c form. Also notice that we have a missing term, a missing quadratic term in this dividend. We have to be careful in these cases. So what can we do with the divisor? We can write up this division in a fraction form. And since we can multiply or divide both levels in a fraction without changing its value, I choose to divide by 3 both levels. Therefore, I will remove this number 3 So I will get my x minus c form as desired. Now in the numerator, I will also have to be careful and divide all the terms by 3. I listed 0x squared as well, because we will need this coefficient in the synthetic division procedure. So let's see, what shall I copy, what shall I write up as a preparation for my synthetic division? I need to list all the coefficients, including this 0, and my new divisor is 2 over 3. Be careful with the signs. Since I have negative here, I will have to have positive here. On the next slide, I will show step by step how to do this division. But I encourage you, try to pause the video, try yourself first, and let's see where you got. Now let's see the division step by step. Copy 15, multiply by 2 over 3, write the solution below this number 2, add 2 plus 10 together, get 12, then multiply 12 with 2 over 3, we will get 8. Let's add 8 plus 1, we get 9. Let's multiply 9 with 2 over 3, we will get 6. Add 6 plus 0, which will stay 6. Let's multiply 6 by 2 over 3, which will give me 4. Add 8 over 3 plus 4 together. I will get 20 over 3. Now multiply 20 over 3 by 2 over 3, which gives me 40 over 9. Last step is add 4 plus 40 over 9, which will give us 76 over 9. And now let's decode what did we get. Separate the last number, which will give me the remainder, and list the polynomial with these coefficients. So my quotient is 15x to the power of 4 plus 12x to the power of 3 plus 9x squared plus 6x plus 20 over 3. But I shouldn't forget about the remainder. The remainder is 76 over 9 and over my divisor. This looks quite ugly with 4 levels, so let's try to find a nicer way, an easier way for this big fraction. I can multiply both levels by 3 first, so I will get 76 over 3, and as a denominator I will get 3x minus 2, and if I would like to get rid of this, I can multiply the whole denominator by 3, so I will get 76 over 9x minus 6. Let's practice synthetic division. Pause the video and try to do these questions yourself. The answers will be shown in 5 seconds. And the answers one by one. Now we're going to discuss our 2 theorems. First of all, the remainder theorem. If a polynomial fx is divided by x minus c, the remainder is equal to fc. How come this is always true? Well, let's see. We can write up any polynomial fx as x minus c times the quotient plus the remainder. Now what happens if I substitute x with c? I have fc equals c minus c plus qc plus r. C minus c is 0. 0 times anything will be 0. Therefore, my first term is 0. 0 plus r is just r. So therefore I can see that FC equals R in every case. What about the factor theorem? A polynomial fx has a factor x minus c if and only if fc equals 0. We can think of this as a consequence of the remainder theorem. Clearly, this is x minus c is only a factor if I have no remainder. Now let's see an application for the remainder theorem. When can we use it? Why would we use it? Well, the method is called synthetic substitution. And let's see what is the task. We need to find fc if my polynomial fx is given and my c equals 4. Well, I know from the remainder theorem that if a polynomial fx is divided by x minus c, then the remainder is exactly fc. Well, I'm looking for fc, so the only thing I need to do is to divide the polynomial fx by x minus c, in this case x minus 4. So let's write up this division and write up the preparations for the synthetic substitution, synthetic division. I have quite many digits, and don't forget about this 0 because I don't have any quadratic terms. Now I give you a minute, please pause the video and try to solve yourself, and let's check if you have the correct answer. Our remainder is 11,165. So therefore, knowing the remainder theorem, I know that this value will be my value in FC, which is F4 in this question. Let's see an application for the factor theorem. Determine whether the following binomials are factors of fx. Let's refresh what the factor theorem is. A polynomial fx has a factor x minus c if and only if fc equals 0. What does it mean exactly? From the remainder theorem, I know that fc is the remainder. That means I need to do the synthetic substitution to check if the remainder is really 0 or not. So I'm going to do the synthetic substitution one by one, first with x minus 1, then x plus 3. You may pause the video and you can try yourself. So I'm going to copy all the coefficients of fx first. Then I will copy positive 1 instead of negative 1 from the first binomial. Do the underline, have enough space between the numbers in the line. Copy the 4, multiply with 1, add to 21, multiply by 1, add to 25, multiply by 1, add to negative 5, multiply by 1, and add to positive 3. My remainder is 48. So what is my conclusion? X minus 1 is not a factor of fx. Let's see the second one, x plus 3. I copy again all my coefficients from the polynomial and negative 3 instead of positive 3. Do the underline, have enough space, copy the 4, multiply by negative 3, add to 21, multiply by negative 3, add to 25, multiply by negative 3, add to negative 5, multiply by negative 3, and add to positive 3. I get 0 at the end. That means that my remainder is 0. which means x plus 3 is a factor of fx. So I can write up the factored form, x plus 3 times 4x cubed plus 9x squared minus 2x plus 1. How do I get these coefficients? Well, I have to check the final row of my synthetic division, and this will give me the coefficients. I brought you one more question to practice factor theorem. Determine whether the following binomials are factors of fx. I recommend you to pause the video, try x minus 6 yourself, then in 5 seconds I will show the answers. Copy all the coefficients, copy the divisor, make sure you put positive 6, not negative 6. Underline, have enough space. Copy the 4, multiply by 6. Add to negative 34, multiply by 6. Add to 54, multiply by 6. Add to 36. This last number, what I've got, is the remainder. What is my conclusion then? The remainder is 0, therefore x minus 6 is a factor of fx. Factored form is x minus 6 times 4x squared minus 10x minus 6. How do I get the coefficients of this polynomial? Well, I get it from the synthetic division. And since x minus 6 was a factor of my polynomial, in the next step, it's enough to work with the quotient only. I don't have to use the whole fx polynomial. I copy only 4, negative 10, and negative 6, and make sure that you have positive 3 instead of negative 3. Copy the 4, multiply by 3, add to 10, multiply by 3, add to 6. That's 0. Therefore, my x minus 3 binomial is a factor of fx. So the factored form is x minus 6 from the previous one, x minus 3 from this one, and 4x minus 2 from the second synthetic division. And as a plenary activity, let's see if the following statements are true or false. I listed 4 statements, so please decide whether the statement is true or false. And if you find a false statement, please try to change it to become true. I'm going to show the statements one by one. All the statements will relate to the remainder, which is r, and the synthetic division. So my r is the remainder after synthetic division of fx by x minus c. And then my first statement is r is the value of fc. Is this true or false? If r is not equal to 0, then x minus c is a factor of fx. Decide whether this is true or false. If r equals 0, then c is the y-intercept of the graph of f. Decide if it's true or false. And please also make sure that if it's a false statement, then you correct it to become true. If r equals 0, then x equals c is a solution of fx equals c equation. I will show the answers in 5 seconds, so please think about them and check the solutions when you have an answer. First was true. We have to change the inequality sign to equal because x minus c is only factor of fx if r equals 0. R equals 0 is only if c is an x-intercept, not y-intercept of the graph of f. And if r equals 0, then x equals c is a solution of the equation of fx equals 0 instead of c.